For this chapter, we're going to be looking at exponential functions, and we're going to start off with the laws of exponents for 7(1) and 0 and negative exponents for 7(2). So starting off with the laws of exponents, these should be review. X to the a times x to the b is x to the a plus b. If I have, for example, 3 to the x times 3 to the second, that would be 3 to the x plus 2, not 3 to the x times 2 or 3 to the 2x. You have to add those. If I'm doing a power to a power, then that is going to be x to the a times b. So, for example, if I take 2x cubed and I cube it, I have to do 2 cubed x to the 3 times 3, which is 8x to the 9th. Okay? Same thing on the next one. It would be x to the b, y to the a times b. So another good example here, let's go 4x squared, y cubed to the third. And so we have to do 4 to the third, x to the 2 times 3, y to the 3 times 3. So that gives us 64. X to the 6th, y to the 9th. X to the a over y to the a is the rule for the next one. You just can take and distribute that in. There's no additions or subtraction signs. So let's take 4x squared over 7y cubed and put that in parentheses and square it. So you could literally write that out twice, or you could use the rule. So it's 4 squared x to the 2 times 2 over 7 squared y to the 3 times 2. So you're taking that 2 and you're distributing it in basically to each one of the monomials. So the result is then 16x to the 4th over 49y to the 6th. And then the last one, we have x to the a over x to the b, and that's x to the a minus b. So when you're multiplying with the same base, you add, but when you're dividing, you subtract. So we could take x to the 7th, y to the 3rd, over x to the 4th, y to the 5th. So we'd have x to the 7 minus 4, and then we'd have y to the 3 minus 5, but that's going to be negative. So if you think about this one, it's y times y times y over y times y times y 5 times, giving you 1 over y squared. So you can almost say you're doing, because it's going to give you a negative, you're going to do the subtraction in the denominator. So we get x to the 3rd over y to the 2nd. And we're going to talk more about the negative exponents. That would have been y to the negative 2, which is really 1 over y squared. Okay, so for the examples down below, 5x squared y to the 3rd is going to be 5 to the 3rd, x to the 2 times 3, y to the 3rd, or 125, x to the 6th, y to the 3rd. The next one is going to be y to the 7 minus 5, because you're doing division, so that's y squared. Number 3 is multiplication, so I'm going to multiply 5 and 6, and then I'm going to add exponents. So x to the 3 plus 2 and y to the 2 plus 1. If there is none written, you assume it's 1. So we get 30x to the 5th, y to the 3rd. Negative 2 to the 6th really means negative 1 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, which is negative 64. Okay, when you have the negative, though, inside the parentheses, then we're multiplying negative 2 times negative 2 times negative 2 6 times, which is going to give us positive 64. Hopefully you see the difference there. And on number 6, we are not going to distribute that 2 in because there's an addition sign, so it's not 25 plus x squared. We actually have to FOIL that. So I get 25 plus 5x squared plus 5x squared. And x squared times x squared is x to the 4th. It's not 2x squared. And then I'm going to finalize that as 25 plus 10x squared plus x to the 4th. And then if I put that in standard form, it's x to the 4th plus 10x squared plus 25. Okay, next. So I've got parentheses, so this in the top means 6 squared x squared, in the bottom, no. So it's really 36x squared over 6x squared. The x squareds cancel, and I just get 36 divided by 6 is 6. For number 8, the 4 does not have an exponent, so it's just left alone. Then we have x to the 2 times 3, which is x to the 6th. And y to the 5th, getting rid of those parentheses, and then 12. Y to the 2 times 3. So, I see some things that can cancel, but I'm going to clean it up first. 4x to the 6th, y to the 5th, over 12y to the 6th. We can simplify the 4 and the 12 to 1 and 3. The y to the 5th and y to the 6th, remember, can be y to the 1st. We do that subtraction in the denominator. So in that numerator, don't forget the x to the 6th over 3y in the denominator. Number 9. So the whole thing is squared. I think what I'll do is maybe get rid of the parentheses and then square it. So slow and steady wins the race, okay? So it's going to be x to the 6th, y to the 3rd. And then that whole thing is squared, which means there's no addition sign, so everything has to get squared. So 8 squared, x to the 4 times 2, y to the 6 times 2. X to the 6 times 2, y to the 3 times 2. There's more than one way to solve these. This is just what I saw. And then that's 64, x to the 8th, y to the 12th, over x to the 12th, y to the 6th. And then we can further simplify some things. X to the 12th and x to the 8th become x to the 4th in that denominator. And y to the 12th and y to the 6th become y to the 6th. And then don't forget your 64. So we get 64 y to the 6th all over x to the 4th. Done. Number 10. Let's see. So we've got x cubed times y to the 2 times 3 times z to the 5 times 3 all over x to the 4 times 2 times y to the 1 times 2, or just y squared, times z. Cleaning it up, x cubed y to the 6th, z to the 15th, over x to the 8th, y to the 2nd, z. X cubed and x to the 8th give me x to the 5 in the denominator. Remember, it's going to give me a negative exponent, so I'm going to bring that to the denominator. And then y to the 6th and y to the 2nd give me y to the 4th in the numerator, subtracting those. And then z to the 15th and z to the 1st give me z to the 14th. So cleaning it all up here, I have y to the 4th, z to the 14th, all over x to the 5th. Okay, to finish up the bottom of these notes, if x to the m equals x to the n, then m equals n. So, you know, if you have 2 to the n equals 2 to the 7th, what would n have to be for that to be true? Well, it'd have to be 7. So, if you can get the bases the same, then you should be able to set the exponents equal. So on number 1, if I can get the bases the same, then I can set the exponents equal. Now, it's more difficult to take a smaller number and bring it to a larger base. So always work with the larger one first and try to bring it to a smaller base. So for 8, you need to be thinking of your powers. So you need to be thinking 8 is equal to 2 to the third. Okay? You need to think powers. Start by looking at the 2 and say, can I write 8 in terms of 2? So 8 can be written as 2 to the third. So we replace the 8 with 2 to the third, and then we just have the 5 still outside, and we have the 2 to the n. So clean that up a little bit, and you end up with 2 to the 15th, using the rules from up above, equals 2 to the n. Once the bases are the same, they basically can drop, and you can just set the exponents equal. So n is equal to 15. And you could check it on your calculator. 8 to the 5th does equal 2 to the 15th. For number 2, start by looking at the larger one. See if you can write 27 using the 3. So 27 is indeed equal to 3 to the third. You've got to be thinking powers. So I'm going to replace 27 with 3 to the third, and everything else is going to remain the same. Then I'm going to clean this up a little bit, and so I have 3 to the n plus 2 equals 3 to the, now you have to distribute here. So it's 3 to the 3n minus 9. When the bases are the same, then we can just basically get rid of them and set the exponents equal. So n plus 2 equals 3n minus 9. I'm going to subtract 3n and get negative 2n plus 2 equals negative 9. Subtract 2, and I get negative 2n equals negative 11. And then divide by negative 2. You could have done that differently too. So I get 11 halves. A little bit harder to come up with that one just by looking at it. We're going to see this again as well, but this will just give you a beginning of it. And then the last one, if 2 to the n plus 2 equals x and 2 to the n equals y, express y in terms of x. So what that means is express y in terms of x. That means that we want our answer to be y equals something over here involving an x. Okay, you'd have an x in the box somewhere. Somewhere there'd be an x in there. Okay, so I can write 2 to the n plus 2 as 2 to the n times 2 to the second. Now why did I do that? Because I see over here that 2 to the n is equal to y. I need to involve a y. Now I just used the rule from up above. If you have the same base, you can add them. All right, they were already added, so I broke it up into a multiplication. I just did the, I kind of did it in reverse, the first rule up above. So now I can replace 2 to the n with y, and 2 squared is really just 4, and this whole thing was equal to x, and then I'm just going to divide by 4. So my answer is y is equal to x divided by 4. I've expressed y in terms of x. All right, let's go to a little bit more with 7-2. So go to the next page. Okay, so today we're going, this time we're going to look at, hold on a second. Okay, the 0 and negative exponents. We already kind of started looking at the negative exponents in the last section. X to the n divided by x to the n is just equal to 1. X to the negative n is equal to 1 over x to the n. X over y to the negative n equals y over x to the positive n. 1 over x to the negative n equals x to the n. And x to the 0 is equal to 1. Okay, so on the x to the negative n. So an example for that. So we had, x to the 5th maybe over x to the 8th. Well, what that gives me is x to the 5 minus 8, which is x to the negative 3. Now remember, I talked about how that would be 5 x's in the top and 8 x's in the bottom, and so you'd cancel them and it'd give you 1 over x to the 3rd. So that's why x to the negative 3 is 1 over x to the 3rd. Now, if we take a look at an example of the x over y to the negative n, so let's just take and do the rule from up above. So let's say we have x to the 5th over x to the 8th, and that is to the negative 1. Okay? So I end up getting x to the 3rd. I get 1 over x to the 3rd in the side there. But I still have this negative 1. If I follow the rule, it would really be 1 over x cubed. Okay, now 1 over x cubed is equal to 1 divided by 1 over x cubed. So here's the big bar, okay, the big dividing bar. So there's the 1 from the numerator divided by 1 over x cubed. Well, that's really equal to 1 times x cubed over 1. So if you look at, and that's just equal to x cubed. So if you look at where we started here, and then what it became, that gives us that rule. 1 over x cubed to the negative 1, you just flip the inside there, and that will make your exponent positive. And if we take a look at an example for 1 over x to the negative n, so if we had, so for example, 1 over x to the negative 3, right? So if we have 1 over x to the negative 3, that's kind of the same as 1 over x to the 3rd. And here we are again, the same scenario as the previous. That's really equal to 1 divided by 1 over x cubed, which is really just 1 times x cubed over 1, or x cubed. So if we look at what we started with on this one and where we ended up with, if it's negative in the denominator, excuse me, it can go up and be positive in the numerator. All right, so some examples. 3 times 6, I'm just going to write out as 18. You know what I did? Yeah, that's fine. To the negative 2 over 4 to the negative 3. And then I'm going to use my rules. Now, with 18 having the negative exponent, it's going to go down to the bottom. And 4 to the negative 3rd is going to go up to the top. I just have other numbers. I don't have 1 over, but those rules are still applying. So when you have those negative exponents like that, they can go up and down. So 4 to the 3rd is 64. And 18 squared, I am going to have to figure that. 18 squared is 324. Just grab my calculator. Number 2, 2x to the 0 is 2 times 1, or 2, versus number 3, which is all in parentheses, that's just 1. Take note, okay? The exponent, there's no parentheses, the 0 in number 2 is only applied to the x. Number 4, negative 2 to the 0 would be really negative 1 times 2 to the 0, which is negative 1 times 1, or negative 1. But negative 2 in the parentheses to the 0, that's 1. Number 6, all right, so this one is going to be 1 over 5 times 1 to the 3rd. You just take that 1 to the negative 3, bring it to the bottom, and you get 1 over 5 times 1, which is just 1 over 5. Number 7, 5 to the negative 2 is 1 over 5 to the positive 2, which is 1 over 25. Just using the rule. Number 8 is 2 over 3a squared b. Now notice that I took that a to the negative 2 and put it down to the denominator. So nothing else had a negative exponent attached to it. So it's going to be 2 over 3a squared b. Okay, that concludes the lesson for today. We'll continue with 7-2, the rest of it tomorrow.